Okay, so for the first thing you have to do is look at the orientation of the tunnel. So it says in the question that it's oriented 65 to 245. 65 to 245. We messed that up in the assignment because I thought this was a plunge and this was an azimuth, but they're both azimuths. So it's just a straight line. So then you go to the stereonet and you go to 65 over here and 245 over here. Line those up northwest. Draw the great circle, which is just a straight line because it's just a vertical cross section. Okay, so then you have to look at this is the cross section of this plane. So this is the apparent dip for B in this cross section. So that means if you look up here, you know the dip direction of B is 14. So I put a point up here at 14 degrees, and I'm going to say that's B dip direction. So I know it's dipping northeast. So now the apparent dip is 60. So if you line the cross section up east-west, apparently the dip is 60. So you go 1, 2, 3, 4, 5, 6. So it's dipping 60 degrees in this plane, but then you have to find the true dip. So the dip direction is this way, so you want to line the dip direction up east-west, and your strike is going to go north-south this way, and it's going to go through this point. So you draw your great circle through there. And you want to put a point on the east-west of the dip. So the true dip of B, if you count in, is actually 70 degrees. I don't know why I started with B, but I did. Okay, now if you do A, you do the exact same thing. So A, the dip direction is 174. So you put a dot at 174. Where am I at? Down here. So A, dip direction. Okay, so now in the cross section, A is dipping at 10 degrees. So that means you line the cross section up again, east-west, and apparent dip in the cross section is 10 degrees. Then you want to do kind of the same thing. You line the dip direction up with east-west, put the strike at north-south, and you want to find your true dip. So you have to go through the point A at the apparent dip in the cross section, draw your great circle, and you count it again, and this is going to be your true dip from the dip direction at A, which is 30 degrees. Then we do the exact same thing for C. You have your dip direction at 263. So right over here, C dip direction. So you line this back up, and the apparent dip of C in the cross section is 40 degrees. So in the cross section, you put another point at 40 degrees. Then you line this back up in the east-west, and you put your strike north-south. And you want to have your great circle again going through the apparent dip in the cross section to find your true dip. And that one comes out to be around 41 degrees. Yep. And then again for the B and C intersection, so you just have to go, you use B and C, so you find the plunge and azimuth of this point, line it up, put a point for the azimuth. The plunge is around 35 degrees at 299. So it's 35 degrees at 299, and that's your answer for number 2. And then 3, you just look at the dip for C, B, and A, and because the middle of the stereonet goes through this wedge, it means that it will fall, not slide.